Okay guys, continuing from our previous lecture. So we stop here, right? I was talking about the human fat milk substitute. Okay, so this is the reaction that the lipases catalyze. So lipase is actually a group of enzyme that can catalyze the lipid. Okay, so the most common one, the first one is hydrolysis of triacylglyceride. Okay, sometimes it can be wrote as TAG, triacylglyceride, or sometimes it can be wrote as TG, triglyceride. Okay, they are the same. Okay, so the reaction, the hydrolysis is when we add the water will break the fatty acid, the triglyceride into free fatty acid and glycerol. So if we have three fatty acid, we will get three free fatty acid here, and usually, not usually, also almost all the time, one glycerol. It can also involve in the process of esterification, which is the production of ester, and also the production of interesterification, okay, which consists of three different processes here. I think there are four, because you can see a blank one here, you can find it yourself. But from here we can see the process is acidolysis, means it happens with probably addition of or the use of acid. The second one is alcoholysis, the uses of alcohol, and the last one is glycerolysis. Okay, we will see about this process more in the subsequent slides. Okay, interesterification, too long, I just call them as IT reactions that lipases catalyze. As you can see here, the alcoholysis, it adds the alcohol, and what happens is one of the fatty acid is transferred here, while the OH group is transferred here. So instead of having three fatty acid, triacylglyceride, now it becomes diacylglyceride. So this one is much healthier than this one because they will have less calories because they have less carbon. Okay, acidolysis, you add the acid. In this case is carboxylic acid, and the same is happening. The fatty acid is transferred here while the R group is transferred here. The transesterification, okay, you add different fatty acid. Okay, fatty acid A, B, C. At the first molecule, the fatty acid D, E, and F in the second molecule, and they rearrange the structure. As you can see here, they become D, B, C for the first one and A, E, E for the second one. The purpose for this one is because different TAG, sometimes they can impart different flavor, texture, or characteristic that can be used in the food industry. Okay, this is the example of the analysis. I think this one is using HPLC. You can see they use the retention time here to detect the compound inside your sample. So this is treated with lauric acid and also of course lipase. As you can see here, this is the product with the treatment, and this is the product with the treatment. You can see new peaks forming here. Okay, and it's the new peak means that there are new product being formed by addition of the acid. Okay. So this is the example of new product that you can produce. For example, the first TAG consists of POP plus the second one consists of SOS. You can produce up to 2, 4, 6, 18 different or 18 new triacylglyceride that can be used in your product. Okay, so B is transesterification of POP and SOS using 1,3 specific lipase. So because for the first one, the A, you produce so many products and it's hard for you to purify, you can use a more specific one. Then you can just produce 3 and then you can purify one of the 3, or you can use all of them. Okay. Also, the second one is about the low calorie fats. Why important? Because it is important to combat the obesity, of course. But the challenges to the food industry is to develop food with reduced both fat and calories, but to maintain the flavor, because fat is an important flavor components in the food. Okay, so what you can do is, by the first one is reducing fat content through replacement with, what is the first one? I'm not sure this one, but okay, you can replace with non-fat material derived from protein. For example, egg, skim milk will constrain ingredient proteins. Okay, so instead of using fat, you can use proteins that can impart the similar flavor characteristic of carbohydrates. Okay, for example, starches, dextrin, maltodextrin, and so on. The second one is they made from fatty acid plus variety of chemical compound. For example, sucrose polyol. Okay, this one is the sweetener, so they have less calories. That either completely or almost completely resist hydrolysis by digestive enzyme. So if they can resist the hydrolysis by digestive enzyme, means that they are not being absorbed in your body, so means no calorie. Okay, same as sweetener. So by adding the sweetener to the fatty acid, you can resist the digestion, and it will go out from your body through the waste product, okay, in the toilet. And the last one is low calorie fat, is by structured lipids that provide fewer than 9 kilocalories per gram. Okay, normally contributed by normal fat. So you can rearrange your structure. For example, you reduce one of the fatty acid, instead of 3 becomes 2. So that then you will get low calorie fats. Okay, so you probably can find what are the other two terms. I'm not really sure what is this one. Okay, this is the example of the synthesis of Olestra to replace the normal fat. Okay, as you can see here, instead of using the glycerol backbone, they use sucrose. Okay, this is the sucrose molecule, and this is the finger is the fatty acid. Okay, so you can see 16 carbon here, 16 carbon here, 16 carbon here. Okay, instead of TAG like this, you get a structure like this, and because the structure doesn't consist glycerol, it cannot be digested by the pancreatic enzyme inside your body. Okay, unlike TAG, which is easily hydrolyzed by pancreatic lipase, Olestra resists hydrolysis, and then you cannot absorb them, so they are low in calories. Okay, so low calories fat, there are these two approaches to produce low calorie fat. Sorry, this is not LCT, this is LCF. Replacing a polyabsorbed long chain saturated fatty fat with short chain or medium chain. Okay, so because long chain, although they are polyabsorbed, they contain more calories, so you replace with the shorter chain of fatty acid. The second one, what you can do is by, okay, this one is at C1, okay, carbon 1 and carbon 3. Okay, you replace the long chain with short chain. Or what you can do is you replace this the first chain and the third chain with the long chain saturated fatty acid, which is polyabsorbed. Okay, so both approaches you can reduce the calories. The first one because less calories inside the short chain. The second one because it is polyabsorbed. Okay, this is the example of the production. Okay, cocoa butter substitute. Cocoa butter means that the fat that you produce from the cocoa during the production of chocolate. They are very expensive. It is brittle at room temperature. Okay, there are 3 types of cocoa butter alternative. So again, you need to fill in the blanks. Okay, so the first one I think is the cocoa butter substitute. The second one is cocoa butter replaces, and the third one is cocoa butter equivalent. Okay, so the first one is similar in physical and chemical properties. Okay, but different from cocoa butter. That means you use something that is equivalent. The second one is lauric plant fat, chemically different from cocoa butter, but with some physical similarities. And the third one is non-lauric fat and have completely different structure. Only in small ratios compatible with cocoa butter. So when you use this technique, you must make sure that although they have different characteristics, they can impart similar flavor, texture, and so on, so that your product won't be so different when using the normal cocoa butter. Okay. Method of bioproduction is by using specific lipase, or you can use the microorganism that can produce lipase to interestify the palm oil milk fraction to produce a product similar to cocoa butter. Okay, because palm oil is much cheaper, then cocoa butter you can use the palm oil as the substrate and use the microorganism to produce similar products. Human milk fat substitute. Okay. In some mother, I'm not very sure if this one is true or not, they cannot breastfeed their children, probably because they don't produce enough milk, or they have depression, or simply because the mother is not there anymore. So we need to give the child, the baby, the human milk fat substitute. You cannot simply give them the cow's milk, because cow's milk is not compatible for baby until they are 6 months old, because the structure of fat is bigger, so the baby cannot digest them. Okay, so what they do is, this company, Loders Crocklin, they analyze the human breast milk, and then they produce something that can mimic them. Okay, so for example, the human milk contains oligosaccharide, which is the carbohydrate, which is shorter form of carbohydrate, but not as small as the 3 simple sugars. Okay, so they mimic this one, and then they make it as a baby formulation. Generally, the main fatty acid of human milk fat substitute are palmitic and oleic acid, while the main TAG is, you click this one, is OPO, okay, alpha beta palmitate. The unique OPO fat structure allows baby to absorb more OSP, palmitic, and also calcium, which contributes to significant nutritional benefit. Okay, so because this structure they cannot be digested, but it can be digested. It cannot be digested by the human enzyme, but can be digested by the microorganism inside our stomach. It is important for healthy gut bacteria as the food for them. Okay, so this is the other advantages. They are both produced enzymatically using palm oil, okay, instead of using milk or cocoa butter, which is more expensive. Okay, and they mimic the TAG structure of the human milk. Okay, so you can see the structure of OPO and also the structure of POP, which is produced from the vegetable oil. They are very similar to each other. This one is in human milk. This one is what is produced in the industry. Okay, and the next one is enzyme modified cheeses. Okay, as you know, this is the production of the traditional cheese. You use the milk as substrate. You put the rennet. You get the curd. You separate the whey, this one, and then you press, and then you ferment, or you store them to get the flavor characteristic. Okay, EMC is, what is it? Can cheese be made from palm-based milk? I think they can, as long as they have the correct protein and fat, the same as the animal milk. Okay, EMC, what is EMC? EMC is enzyme modified cheese. It is a little bit different from the conventional or traditional cheese making, and usually being used differently. For example, the traditional cheese, we eat what we call the hard cheese, but this one is soft cheese. You can find them, for example, in the KFC, what we call it, the cheese sauce, and also the cheese powder, but they are not the hard cheese. Okay, used to impart or intensify the existing taste of cheese. Okay, made similar way to processed cheese, except use immature cheese curd, which is here, immature cheese. Okay, you don't store them, so they are still soft. A slurry of immature cheese curd, which is soft, is treated with high dose of mixture of enzyme, usually protease that can digest the protein, and lipase that can digest the fat. Okay, and incubated for only 1 to 3 days instead of years inside the hard cheese. Okay, after incubation, the mixture may be sterilized, so they can be kept longer and either be used as paste. Okay, for example, the KFC, the cheese sauce, or powder. Sometimes you can buy the cheese powder, right, to use in the crackers, biscuits, and so on. So this is a process. Okay, you can take a look. You can see here. Okay, the cheese slurry, okay, they are not being stored, but instead they are being pasteurized, cooled, and then added the enzyme, and then re-pasteurized, so they can be kept longer.